Hello, and welcome to Money Doesn't Grow on Clouds. This presentation is about Cloud Custodian and controlling your cloud costs with it. So first off, what is Cloud Custodian? It's basically a open source rules engine for managing your public cloud accounts, such as AWS, GCP, Azure, and it uses simple policy files, which allows you to achieve your security, operations, and cost optimizations goals. It consolidates many of the ad hoc scripts that a lot of organizations tend to write when they get started to try and manage their infrastructure, and it replaces it in a much simpler form, much easier to manage, and provides unified metrics and reporting. And it integrates with the cloud native serverless capabilities, so you can deploy policies across serverless things such as like a Lambda function, etc. Or it can also be run in simple cron mode, so you can execute against large existing fleets from an existing server. And we are part of the CNCF. So for cost savings, things to look for. Here are some of the common resources where you can achieve a lot of cost savings, but this is definitely not a complete list. So we'll be covering some examples with each of these. First off, we'll start with the Azure Orphaned disks. So if you have Azure accounts, this is a simple policy you could run and to identify those. And you can see it's running against the resource of azure.disk. And just filters looking for where the disks are not managed by anything, so with the value of null. So this is a great way if a server was maybe decommissioned, the instance, and the disk did not get cleaned up, this is a great way to identify those and get those cleaned up. Next, we'll move to AWS Orphaned EBS Volumes, very similar to the Azure one, but the resource just changes to AWS.EBS. And for the filters, we're just going to look for a empty attachments array. So basically, if that EBS volume is not attached to anything, it is considered orphaned and is a great candidate for cleanup. Next, we're going to move to the AWS EC2 Off Hours. This is a very good policy if you have a lot of developer instances in your AWS accounts. This can save over 76% cost savings, depending on the hours that you run it for. If you're just running it, having your servers up for about 8 hours a day while they're being used and shut off on nights and weekends, this is a huge cost savings. Some companies save millions of dollars by running this policy. And so how this works is it's running against the resource of AWS EC2. And we have a policy up here at the top, which is for EC2 stop after hours. And then you'll notice a policy down here, which is start the after hours instances. And in the filters, you'll notice we're using the simple off hour type filter. We're specifying a tag of custodian off hours to look for on the instances, a default time zone, and this is Pacific time zone. And then the default off hour, so this one's at 1900 hours, so 7 p.m. And then it basically would identify any EC2 instances that have this custodian off hours tag present, and then it would stop them at the default hour unless they have a schedule defined within the custodian off hours tag on the instance. And then the next policy here is also running against EC2, but you'll notice the filter type is now on hour. It's looking for the same tag name, same time zone, and the default on hour is set to 7 a.m. here with an action of start. So this will look for any EC2 servers that have that off hours tag, and if they have a schedule on them, it would turn it on based on that schedule. If not, it would turn it on with the default on hour of 7 a.m. and start them up. So those are, obviously these are not great for production servers, but for those developer servers that don't need to be on all the time, this is a massive cost savings and highly recommended. Next, we're going to look at EC2 instances that are underutilized. And so once again, we're looking at the resource of AWS EC2. And in the filters, we're doing a metrics type filter. And then we can point to any metric name within the EC2 service space within the metrics, CloudWatch metrics. In this case, we're looking at CPU utilization over a 14-day period, with the actual metric scanning period being 1 day. And we're looking for a value of less than 30%. So the OP, or the operation, is less than value of 30. So we're basically looking for any instances that over the last 14 days have had an average CPU utilization less than 30%. And so these attributes can be modified. You can change which metric it's looking at. If you have a memory metric that you're populating, you could change it to look at that. But this is a great way to kind of find those instances that are maybe oversized and underutilized, that are kind of wasting costs. And you can even add actions on here to automatically resize the instances by specifying a instance class type and size. And so very powerful. Obviously, each instance class that you go up, the cost typically doubles. So if the server was not using much CPU and was way oversized, then you could save 50% or more by resizing it down to a smaller size. Next up, we're going to look at the AWS ELB Unused. So this one's just using the AWS ELB resource, which is the elastic load balancers. And for filters, we're just saying if the instances attached to the ELB are empty, so there's nothing attached to it, it is unused and you're being charged for it. So at that point, it'd be good to kind of notify and track those maybe over a 14-day period or so. And if they're still not used, you can have an action to automatically delete them. Next up, we'll look at the RDS No Connections. So this is kind of similar to the EC2 Underutilized, where we're using a metrics filter to kind of see the utilization on that. And we also have an additional filter here. You'll notice the type value type of age. So we're looking at the database instance create time and saying if it's greater than 14 days old, and there's an inherent and on filters. So if the database instance is greater than 14 days old and looking at the metrics, the database has had 0 connections over the last 14 days, then that's a decent indicator that that is not being used. However, there are some caveats where some programmatic database access might not show up as a connection. And so this would be a good one just to maybe notify the owner and ask them if it's still being used or not. You wouldn't necessarily want to just delete this based on just these filters alone, because like I said, it still could be, the database might still be accessed by a program or something like that, where it's not registering actual database connection. So just something to be aware of on that. And finally, we're going to look at AWS Unused Workspaces. So within AWS, we're looking at the Workspaces resource and basically saying filters here. If the workspace properties.running mode is set to always on, so this is workspace that just is always running and doesn't power off, and the connection status age of the last known user connection timestamp is greater than or equal to 30 days ago, then nobody has logged into that instance, that workspace, in the last 30 days. And that's a pretty good indication that it's not being used. And you can notify the owners of those workspaces at that time and ask them if they're not using it to either shut it off, terminate it, etc. So thank you for checking out a few cost-saving policy examples, just a high-level overview of some simple things you can do to identify cost savings. If you'd like to get help or learn more about Cloud Custodian, a great way to do that is to join our Gitter community, which has 1,500 plus members, and is a great way to get your questions answered and learn lots about Cloud Custodian. And also to get started with Cloud Custodian, check out our GitHub repo, and lots of great docs, policy examples, and tools there to get you started. Thank you.